All right, so this is a big chunk, a big section here about Archimedes' principle. Archimedes is just a scientist who kind of came up with this really beautifully simple idea. Sometimes people tell a story about how he did it with a gold crown or something, but the premise is quite simple, but the magnitude or the repercussions of it are actually really, really big. And so his principle is related to buoyant force. And so he says that the buoyant force on an object is equal to the force of gravity, or we will just call that the weight, right? We know that force of gravity and the weight are the same of the displaced fluid, or of the fluid that it displaces. So most of the time that is water. So super, super simple here. We could see an image of it, and hopefully you did kind of an introductory lab where you saw something similar. The only thing I don't love about this particular image is that they're using newtons as forces, they're using kilograms as forces, and we know that that's a mass, not a force. So let's just pretend that all of these are newtons, because other than that, the premise is the same. And so there's a super cool relationship that he figured out, Archimedes, that when we submerge this, the water is going to put a force, an upward force. We know that, right? The buoyant force on there. Well, that buoyant force happens to be the same force as the weight of your displaced fluid. Okay, so if you had a 2 upward force, or 2 Newton upward force, the fluid that you would get out of there would have a weight of 2 newtons, right? A force of gravity of 2 newtons on it. There's this nice relationship between that. And so if you displaced a heavier fluid, or a more dense fluid, I should say, then you would actually have a bigger buoyant force for something that is more dense. So super cool principle. To get the equation for it, we just want to go back to our density equation. Remember, density is mass divided by volume. If we rearrange that, then mass, we just multiply by volume on each side, we can get mass equals density times volume. Not super important for now, but this is just leading us down here, if I can get my marker to go. And what they're saying is, hey, Archimedes tells us that the weight of the displaced fluid is the same as, the weight, which is force of gravity. Okay, remember, force of gravity is mass times g. That is the same as this PVG. That's coming from, we take this PV, we plug it in for M, and we end up with this. Okay, all this is, guys, is the derivation of where this formula came from. But if that was lost on you, honestly, it doesn't matter for right now. All that you need to know is that leads us to a new equation where that buoyant force, same as the weight of our displaced fluid, right, because we know that weight is Fg and all that good stuff, that buoyant force is equal to the density of the fluid. Maybe we should label these. They're kind of labeled right here, but we'll just relabel them again. I'm going to go not in highlighter. The P here is the density of whatever fluid you submerged the object in. For our class, it's almost always going to be water. The V here is the volume of water that is displaced. So volume of, I'm going to say water, but it should really just be any fluid displaced. Okay, so in this case, it'd be like what spilled out. There are other ways to calculate that, but we'd have to figure that out. And then G is just like it's been all along. This is our gravitational pull. We could use 9.81, or we're just going to stick with G equaling 10 again for this unit. Okay, so the buoyant force, this is just a new equation for us. You just take the density of the fluid times the volume displaced by the object times 10, and that will give you your buoyant force.